Hi everyone, I am Junjie Yin from the Forest Lab in Physics. Today I'm talking about stable polystyrene glasses through PVD and UV radiation. To make glasses, we cool the liquid, and if crystallization is avoided, we enter the supercooled liquid regime. Particle motions slow down as we cool, and the system falls out of equilibrium and goes to curve 1, forming a glass. If we cool more slowly, we can get a denser and a more stable glass like curve 2. Recently, a convenient way of making stable molecular glass was discovered, where instead of cooling a liquid slowly, physical vapor deposition, or PVD, was used. Glasses made this way can have increased density and kinetic stability that would take millions of years to achieve in the conventional way. In our lab, we have applied PVD to make stable glasses with polystyrene. Due to difficulties in thermal evaporation of polymers, the highest polymerization index N we get is around 12. In this study, we start from here and make higher molecular weight stable glasses with UV crosslinking. With UV radiation, monomers are cross-linked by dehydrogenation to form a network system. We notice the as-deposited film dissolves very easily, whereas with longer UV treatment, the film gets harder and harder to dissolve, which means it's growing into a network. Compared with the as-deposited film shown on the top, the cross-linked glass on the bottom also shows kinetic stability and enhanced density, although not as much as the as-deposited glass. What we think is happening is when covalent bonds are formed with UV treatment, they might to an extent disturb the dense packing of the molecules and cause them to be less stable, although they still maintain part of the stability. In conclusion, with PVD and UV treatment, we can make polystyrene network stable glasses, although the stability is affected. In the future, we will do a more systematic study and figure out what is the most stable network glass that we can make, or how to minimize the loss of stability due to UV radiation. Thanks for watching.